Well, hello. This is working through the solutions to the questions from your third midterm exam. So this first question, you're given the molecular formula for approximation of coal, and you want to know the percent carbon. And so what you do is take the whole molar mass of this, and so let me pull up a periodic table here. Okay, and so using 12.01 for carbon, hydrogen is 1, oxygen is 16, nitrogen is 14, and sulfur is 32.1. Okay, so that's where I'm getting these different values from. If I put that in the calculator, it's 135 times 12.01. And then we've got another 96 for the hydrogen. We've got 16 times 9. And then 14 for nitrogen and 32.01 for sulfur. So I get 1907.36 grams per mole for this whole thing. And I just want to know carbon. So it's really just the 135 times 12 divided by this whole thing. Okay, so 135 times 12. So that's 0.85, and then times 100% because you want to know the percentage. That's 85%. Okay. So this, just from the reading from chapter 4, without natural global warming or the greenhouse effect, we'd be at minus 18. Mass percent of sulfur in this. So similar question to the first one. So we take the whole molar mass, and so aluminum, I don't have that one memorized, is like 26.98. And we have 2 of them times 2. And then we've got 3 sulfurs. Notice that the 3 is outside the parenthesis, so that's 3 sulfurs. So you've got 2 aluminums, 3 sulfurs, and 12 oxygens. That's 4 times 3. So sulfur is 32.1 times 3, and then 12 times 16. So I get 342.26 grams per mole for the whole thing. And you want to know just sulfur. So that's going to be 3 times 32.01. So that's 28.1%. Okay, molar mass of this guy. So it's, you have 2 hydrogens, 1 carbon, and 3 oxygens. So that's, each hydrogen is 1, so that's 2. And then you have 12.01 for the carbon, and then 16 times 3. So that's 62.01 is what I get. It'll all depend how you kind of round, so somewhere in that realm. Okay. So the balance, so this is balanced. Just double check to make sure it's balanced. So for instance, 12 oxygens, and here you've got 6, 7, 8, 9, 10, 11, 12. So that's good. Like 7 hydrogens on the left side. No, we don't. 8 hydrogens on the left side, 8 on the right. Okay, so everything is balanced properly. So now if you're given 288 milligrams, so 288 milligrams is 0.288 grams. Okay, and then to get the moles, we divide by the molar mass of that. So that's each oxygen is 16. Okay, and you have 2 of them, so that's 32. So this will give you the moles of oxygen. So that's 0.288 divided by 32 is 0.009 moles of oxygen, and we want to know moles and grams of CO2. So this is where you do, it's a 6 to 3. Okay, so if we want to know moles of CO2, you are multiplying by 3, dividing by 6, or in other words, just dividing by 2. Okay, so 0.009 divided by 2 is 0.0045 moles, and then the grams you have to multiply by the molecular weight of CO2. So that's 16 times 2, and then you have another 12. So that's 44 grams per mole. So I get 0.198 grams of CO2. Okay, covalent bonding, so that's sharing of electrons, just the definition. This greenhouse gas, so it allows visible light to pass through, but it prevents heat from radiating, so it traps the heat, just like a greenhouse. Okay. So if you have so many moles of lithium, how many grams of this guy? So it's a 6 to 2 relationship. And so if we have 1.75 moles of lithium, you are going to multiply by 2, divide by 6. Okay, so again, what you're going to is on top, what you're coming from is on the bottom. So that's why I have 2/6. Okay, or you could divide by 3. Okay, and so 1.75 times 2 divided by 6 is 0.583 moles, and then you have to multiply by the molar mass of that. And so lithium is 6.94, and you have 3 of them. And then nitrogen is 14.007. So you are multiplying by 34.827 grams per mole. So that's the molar mass of Li3N, just from the periodic table. And you get 20.3 grams. Okay. How many molecules of H2S? So it's going to be a huge, huge number. Are required to form 79 grams of sulfur. Okay, so if you're given this, so 79.0 grams, you can get the moles. Okay, and so again, you know, one thing to keep in mind, if you have moles, grams, and number, this is where you want to end up. This is where you're starting from. So you're going to have to go here, and then to there. Okay, and then so again, remembering, you know, to get out, you're multiplying, this you're dividing by, and this is the molar mass or molecular weight, and this is multiplying, dividing by Avogadro's number. Okay, so keeping that in mind, if you divide by the molar mass, or I guess atomic mass here of sulfur, that will give you moles of sulfur. So that is 79 divided by 32.1 gives you 2.46 moles of sulfur. Then you multiply by Avogadro's number. (1.48 times 10 to the 24th). Oh, whoops, what am I? That is for sulfur. Oh, and it's asking for H2S. Okay. So I didn't read the question properly. Okay. All right. I guess what I didn't do is do the conversion from this to H2S here. So it's really, so I've got the number of, I guess, atoms for sulfur here, but you want to know for H2S, and so it's really 2/3 of this number, right? So times 2/3 times 2 divided by 3. Whoops. Divided by 3 gives you 9.87 times 10 to the 23rd. Okay. So again, so what I did here, I did moles of sulfur multiplied to give you, this is, atoms of sulfur, but it's asking molecules of H2S, so that's why I had to do times 2 divided by 3, so you take into account these ratios there. Okay. All right, see, read the question this time. How many molecules are in that? Okay, so if you're starting from grams, so you have 76.3 grams, you divide by the molar mass, which will give you moles first. So that's 0.829 moles. And then you multiply by Avogadro's number. So that's 4.99 times 10 to the 23rd. Okay, how many moles of nitrogen when you have so many grams of this? Okay, and again, double check that is balanced. And so 58.6 grams, and then you divide by the molar mass, which actually is given. So 58.6 divided by 101.11. So that's 0.5796, we'll say, moles. And we want to know moles of nitrogen. And so it's a 4:2 relationship. So again, you're multiplying by 2 divided by 4, or divide by 2, or multiply by half, I guess, whatever you prefer. So divide that by 2, gives you 0.28978 moles of nitrogen, and it's asking, I guess that is not even grams, so you're done. So 0.290 moles, I guess, rounding to 3 sig figs. This one, just an extrapolation question. So if the average temperature is 15 degrees, what does it predict in 2080? So you're just kind of reading up here. It's going to be about 2.5 degrees higher. So that's 17.5 degrees. Okay, so, plus or minus 0.1 there. Climate models have to take into account all of these. Okay, so that's just really from the reading here. Lowest electronegativity. So if you look at the periodic table, the highest will be fluorine. The lowest will be something down here, and so, or the left side of the periodic table. So you've got between calcium, magnesium. So calcium would be lower, magnesium would be a little higher, and then you have chlorine and bromine are the other choices. So those are going to be the highest. Again, bromine, amongst bromine and chlorine, that's going to be the lowest, and that's going to be the highest. And so the highest electronegativity amongst all those listed is going to be chlorine. the lowest is going to be calcium. Okay, so it's calcium. So again, just a definition, or I guess from the reading. So ice core samples, they get those ratios of the isotopes. Industrial Revolution, why it's important. So there were, prior to that time, there weren't a lot of fossil fuels being used. The carbon cycle, just another definition. And then we get into our first geometry. So bromate, Bro3 minus, and so you do how many valence electrons? So we've got 6 for each of the oxygens, so that's going to be 18, another 1 here, and then 7. So 18, another 1, so that's 19, and 7, so 26 valence electrons. And so you can put it around any way you want first. And so we have 6, 8, 9, 10, 11, 12, 18, 19, 20, 21, 22, 23, 24, 25, 26. So this is your AX3L. Okay, and so that will be trigonal pyramidal. So based on your little cheat sheet there. The most abundant greenhouse gas, so we talked about this in the chapter and in lecture, so that's water vapor. It's really not CO2. This is like 420 ppm, which is the most it's ever been in history, but water vapor is a lot more than that. So greenhouse gas emissions, so the Kyoto Protocol. And then what mass is this many molecules? So in this case, if I go up to our little chart, we're now starting here, and we want to know there. Okay, so we're going to have to go divide by Avogadro's number first to give you the moles. Okay, so 6.89 times 10 to the 25 divided by Avogadro. So 6.89 e to the 25th divided by 6.02 e to the 23rd gives you 114.45 moles. Okay, we want to know the mass, so let's multiply by the molar mass of this, which is 44 grams per mole from the periodic table. That's just carbon, and then add in 2 oxygens. So times 44. And so we get 5036 grams, which, if you're going to convert to kilograms, you divide by 1,000. So that's 5.04 kilograms. ASCl3, so that has how many valence electrons? So arsenic is in the same group as nitrogen, so it's going to be 5. And then each of the chlorines is 7. So it's 21, and 5 is again 26 valence electrons. Whoops, not aluminum. Arsenic. Okay, so I place 6. 526. Did I give you the same one again? I guess I did. Trigonal pyramidal here. So 2 questions of the same structure. Oh, great. Okay. This one, TeCl4. So tellurium is in the same group as sulfur, so that has 6 valence electrons. And each of the chlorines have 7. So you have 28 and 6. So that's 34 valence electrons. So that's 8. 3, 34. So this is your AX4L, which is the seesaw shape. So the highest concentration of CO2, so we have about 400 ppm. Most of the carbon is stored in fossil fuels or carbonate minerals. So we saw that in the first section of chapter 4. So what are characteristics or a problem of global warming? Increased sea level, alter climate is for sure. Heat radiated by Earth is captured by atmospheric molecules, yeah. Increased skin cancer, so that is what we saw in a previous chapter. That has to do with UV and the ozone layer, so that's not. And then again, talking about ozone, so that's a different context. So these are really the only ones for climate change. So this is important to know for the final as well. I'll usually put one of these similar kinds of questions on the final. So global warming or climate change has nothing to do with UV radiation or ozone. And so cloudy nights are warmer than clear because clouds are composed of water vapor, and water is a very strong greenhouse gas. The longest bond, so a single bond is going to be longer and weaker than a double, or I guess that's a triple, and also than a double. Okay, so this in order of length, that's going to be longer than that, which is going to be longer than that one. Okay, so this is like, why can't I? There we go. This is increasing length and also decreasing strength of the bond, which are expected to reduce the level of atmospheric carbon. Decaying plant animal remains, that is going to increase CO2, growth of trees for sure, and formation of carbonate rock, and animal respiration is not. Okay, so kind of just a review of the carbon cycle. So 2 and 3 are reducing the level or sequestering carbon, not reducing. So, for respiration or photosynthesis, plants take in CO2 while animals exhale CO2, which should be nonlinear. So remember, as soon as you have two lone pairs on the center, that is our AX2L2, so this is bent. If you don't have anything, that's just AX2, which is going to be linear. And then this one, that's our AX2L3, so that is also going to be linear based on shapes. Okay. Carbon sequestration. So similar to the previous question, really. So planting trees, deforestation, no, that's bad for climate change. And then pumping CO2 deep in the ocean, that would be an example. Increasing combustion, that's releasing, so that's also not. So it's really 1 and 3 in that case. And then the last question, the greenhouse effect, just the definition again. So radiated by Earth is absorbed by the atmosphere. Okay, so I hope that helps. As always, let me know if you have additional questions. Take care.